Hi everyone, welcome back to the final part of our deep dive into chapter 3. We have already learned how to keep functions small, focused, and minimal with their parameters. Today we are covering the final mechanics of writing clean functions. We will discuss why hidden side effects are lies, how to separate commands from queries, the art of clean error handling, and the ultimate rule of software design: don't repeat yourself. Let's jump straight into the slides. Functions are the verbs of your system's domain-specific language. Writing them is a foundational mechanical skill. In this final section, we will explore how avoiding side effects, separating commands and queries, and handling exceptions can turn your codebase into a story that reads effortlessly. Let's start with a major cause of production bugs: hidden side effects. A function's name is a promise. When a function promises to do one single thing, but secretly changes background data, it tells a lie. These hidden side effects are dangerous because they create temporal couplings. This means your function can only be called safely at specific times or in a specific order, which easily confuses other developers. Let's look at this in practice. Consider a function named checkPassword. By its name, it simply checks a password and returns a Boolean value. But look at this line, it secretly calls session.initialize. This hidden change is completely invisible from the function's name. If a caller runs this function just to validate a user check, they might accidentally wipe out existing session data. If a temporal coupling is truly avoidable, you must make it clear in the name, like check password and initialize session, even though it violates the rule of doing one thing. Next, we must avoid output arguments. Naturally, we interpret function parameters as inputs. Look at this example: append footer as. Does this append as a footer to something, or does it append a footer to s? It forces a cognitive double take. In modern object-oriented languages, the object itself is meant to be the output argument. We should write it as report dot append footer. If a function must change the state of something, have it change the state of its owning object, not external parameter. Another golden rule is command query separation. Functions should either do something or ask for something, but never both. Look at this confusing conditional phrase: if set username, comma Uncle Bob. Is set a verb or an adjective? Does it check if the username is already set, or does it confirm a brand new assignment? The reader can't tell. Renaming it doesn't fix the core structural ambiguity. The real solution is to separate them completely. Check if it exists first using a query, and then run your commands separately. We should also prefer exceptions to error codes. Returning error codes is a subtle violation of command query separation because it forces you to use commands as expressions inside predicates. Look at the red text on your screen. Using error codes leads to deeply nested error handling structures, creating a nested if-else hell. By switching to exceptions, the normal happy path reads beautifully and cleanly, while error processing is completely isolated in a dedicated cache block. Extract try-catch blocks. However, try-catch blocks are inherently ugly on their own. They mix error processing with the actual business logic. The solution is to extract the bodies of try and cache blocks into separate functions. Look at the uh, after example on the right. The main delete function handles error processing only. It calls delete page and all references, which handles the poor business steps. This works perfectly because error handling is one thing. If a function handles error, it should do nothing else. To keep error functions clean, remember two strict rules. First, a try comes first. If the keyword try exists in a function, it should be the very first word of that function. Nothing should ever precede it. Second, nothing after cache. There should be no code lines following the catch or final blocks. The function's entire single purpose is error handling. So once the error is processed, the function must end immediately. When you use error codes, you usually create error enums. These enums are dependency magnets. Every single class that imports them must recompile whenever a new error type is added. Exceptions are for superior because you can derive new ones without forcing recompilation. This brings us to the root of all software evil, duplication. Duplication bloats your code and multiples opportunities for maintenance errors. Think of OOP-based classes, database normal forms, and clean methods. They are all architectural strategies designed to eliminate repetition. Finally, let's look at structured programming and how to actually write clean functions. Dijkstra's uh, Dijkstra's rules state that every function should have only one return, no breaks, and no continues. But these rules provide little benefit when your functions are very small. If you keep your functions short, multiple returns or breaks are harmless and even expressive. Remember, you don't write clean functions from the start. No one could. First drafts are always clumsy, long, and duplicated. The art of programming is to message, refine, split, and polish that draft until your system reads like a beatable story. Uh, that brings us to complete end of chapter 3. We have learned that master programmers look at systems as stories to be told rather than programmers to be written. Functions are the verbs of that language, and classes are the nouns. By applying this guidelines, you can write systems where everything happens exactly where the reader expects it to. And thank you so much for following along with chapter 3. Don't forget to like this video, leave a comment with your thoughts, hit that subscribe button, and as always, stay professional.